Okay, hi everyone, and welcome to the last brown bag before Jfokus conference next Tuesday. Today we have with us Grace Jansen from IBM, and she will talk a little bit of what does cloud native mean anyway. So hello Grace, please introduce yourself.
Hi, so I think I've met some of you before. I've spoken at the last two Jfokuses. I'm very fortunate, and I'll be attending this one coming up as well. Jfokus is actually where I first started presenting, so I do love the Jfokus community. Yeah, I'm a developer advocate at IBM. I work primarily in the UK, but I do travel a bit for conferences, and I focus sort of on reactive, cloud native, application architecture type field, and those sort of topics. So I'm just going to get started and share my screen. Hopefully this will work without a problem. Yeah, all good. I'm getting the nod. Great. Okay. So yeah, I'm here to talk today about sort of what does cloud native mean anyway? It's become this really charged term and is often associated with specific technologies or with specific architecture types. So I'm here to sort of break it down and perhaps change your perspective about what cloud native really means. I have Twitter if you want to follow me on Twitter. And yeah, as I said, I'm Grace Jansen and I work on a product called Open Liberty. So what does cloud native really mean? So people kind of think they have this common understanding of what cloud native really means, but often a big part of that is microservices. But this year in particular, but as well, it's sort of grown over the past few years, is the idea that perhaps microservices aren't this sort of panacea that they were previously believed to be, this sort of answer to everything. So it's a good time for us to sit back and start thinking about what this term really means and whether microservices has to be a part of that. For some people, the term cloud native can mean something like Spring Boot, but this can't be the definition of cloud native, because there are many, many other people building perfectly great cloud native applications with things like JavaScript with no problem at all. So it's definitely not about a technology, it's something else. So what does it really mean? So to look for answers, I went online and I essentially looked at different vendors that sell software that they claim to be cloud native. And I took a look at what they define cloud native to be. So the first one I came up against was VMware. So for anyone who's not sort of come across VMware before, VMware are responsible for sort of VMware virtualization. They also offer things like Tanzu Kubernetes platform, and they're also responsible for things like Cloud Foundry and also Spring Boot. So they do have this sort of long running history of being in the cloud native environment. So what do they say? Well, their definition is kind of interesting because they don't refer to it as a sort of thing. They refer to it as an approach. So an approach to building and running applications that exploit the advantages of the cloud computing delivery model. And actually, you can visit their documentation, and in their documentation, they go on to further describe cloud native development as incorporating 4 key concepts. And you can see from the diagram here, those key concepts are DevOps, continuous delivery, containers, and interestingly, they include microservices. But it's actually that inclusion of microservices that I'm questioning. Is this really necessary to explicitly link microservices with cloud native? Well, if we take a look at another definition from another vendor, so we've got Microsoft here, and with Microsoft, they have this really large document that sort of defines what cloud native is. So I've just sort of picked out a few key points here and sort of their key diagram. So in this document, they sort of highlight things like it's about speed and agility. But these, to me, represent values that we want to achieve through using cloud native, but it doesn't really tell us much about what cloud native is. Further down in their document, it does help in terms of they provide this diagram where, again, they mention these key concepts that they associate with how you build cloud native apps. They have sort of similar concepts to the VMware definition, where they've got things like containers, they've got things like backing services, so things you'll find available in clouds, automation, so that sort of maps to the DevOps and the continuous delivery aspect that was mentioned in the previous slide, and modern design. So in this case, in the diagram, in the document, they actually drill down on the 12-factor application. But again, interestingly enough, they have microservices included. And actually later on in the document, they actually specifically say cloud native systems embrace microservices. So again, similarly, they identify microservices as a key part of cloud native. Now, taking a look at sort of another example, so Red Hat, another very cloud native sort of business, actually, they're interesting with their definition because they start out at the beginning of this documentation with quite a strong statement. So they say cloud native applications are a collection of small, independent, and loosely coupled services. This is interesting to me because although they don't state in that sentence microservices, by stating that they have to be small, independent, and loosely coupled, they're sort of describing microservices innately. It's sort of the byline of microservices. And actually later on in the page, they do actually mention microservices specifically in their diagram. So again, they pull out these key concepts, very similar to what we've seen before. So DevOps, containers, and again, they mention microservices. And in this case, they pull out APIs as the fourth one, perhaps because they view continuous delivery as sort of part of DevOps. So as you can see, all of these companies sort of have this similar vein of describing cloud native as how you develop and deploy microservices. But actually, interestingly, in the Red Hat definition, if you keep going down their documentation, they actually say specifically that you don't always have to start with microservices to speed up application delivery as part of cloud native apps. So it's interesting that they sort of almost go back on themselves to say that although microservices are important, there are also other ways in which you can build cloud native applications. And this is sort of the first time that I, when I was researching it, saw sort of an acknowledgement that microservices weren't necessarily or 100% the best way to get value out of the cloud. So it's sort of interesting to see that mention in that website. Now, obviously, these are all vendors that I've gone to, but I thought, who better to get a definition of cloud native than the Cloud Native Computing Foundation? The clue is in the name, so they should have a pretty good definition of what cloud native is. So in their definition of cloud native, they actually sort of, it's kind of interesting because they talk about containers and they talk about microservices and other things like declarative APIs, service meshes, infrastructure, but they describe it as a way to exemplify the approach of cloud native. So it's more about sort of saying, you know, this is how you empower organizations to build and run scalable applications. But actually, what they define as cloud native is building and running applications or sort of scalable applications in the cloud. So it's not necessarily about using these specific approaches. It's just these are approaches that could help you in building cloud native apps. So whilst microservices, they say, are a good way to do this with containers, they do actually acknowledge that, you know, there are other approaches that can fit with this style of sort of infrastructure underneath. So what's interesting from the definitions that we've just seen is that they vary a bit, but in general, they have this sort of common technology choices, but a technology choice isn't really what the definition of cloud native is. So they all refer to microservices, which does lead to a discussion of sort of which application architectural styles are appropriate for cloud native. So there is a spectrum of architectural styles that we're probably all aware of. So you've got sort of the more coarser grained on the left-hand side of this diagram and the more finer grained on the right. So cloud native is really about sort of going beyond the core architectural style, going beyond it, sort of the design of your application. It's about how you deliver your application and your services. So functions, as an approach for software development and delivery, is definitely a very cloud native thing that you could come up with. It's probably the most cloud native thing you could come up with in terms of application architecture. And this is because you can deploy functions on premise, but most people who deploy functions deploy it in the cloud, and they're paying per usage, and how many calls they basically pay depending on how many calls to the function are made. And that model doesn't really work if you're running that on premise. You don't really get the benefits that you're paying for the hardware. So functions is really cloud native application architectural style. If we sort of get more coarser grained than functions, we start looking at microservices. Might be a little bit amusing that we're referring to microservices as somewhat coarser, but you do tend to have more functions than you have microservices. And this is sort of where the industry has been trying to derive this sort of cloud native term and the value in cloud. And whilst there's been a lot of sort of notable successes like Spotify, Netflix, where these companies have sort of gotten a lot of value out of microservices, it doesn't necessarily work best for everyone. And there is a continuity of lots of different styles that you could take. So actually, if you start reading perhaps some of the Gartner reports and their hype cycle, interestingly, actually, microservices and functions are at the moment in the trough of disillusionment. So this is sort of backed up by stories of organizations who have tried to do the move to microservices and actually have failed in doing so. It's not necessarily been the right approach for them. So there is sort of a growing appreciation for perhaps other architectural styles that could still be beneficial and still gain value from moving to cloud and becoming cloud native. Actually, you don't necessarily have to just believe me. There's been many different sort of companies that are starting to sort of talk about different architectural styles. So some of the early adopters of microservices have actually been talking about combining them. So combining some of the microservices together to be deployed as sort of a more larger version of the microservice. And it's sort of being termed as a macroservice. So the example in this diagram you can see here, we've got 3 sort of deployable chunks with the set of services within them. So it's not a monolith, but it's more like sort of mini monoliths that have really well-defined APIs around them. So depending on your development organization or maybe the structure of your organization, this can provide a lot of value and a lot of sort of, you can still gain a lot of value from moving that to the cloud. And then on the very right-hand side, we do have sort of the true monolith, which when you think about it, doesn't necessarily always exist because it's very rare that you find that an application is just coded within a single application. There are very few sort of examples of just pure single monolithic applications. Often there are, external services that they rely on and they have to link to, but that's obviously another type of architectural style. And actually, interestingly, all of these could be built to be cloud native. And this is sort of where it gets interesting. Some may be more obvious than others. So maybe functions and microservices are sort of the more natural, more obvious styles. But importantly, there's nothing intrinsic about these architectures that means that they can't be sort of built and designed in a way that's cloud native. And actually, when you start looking at the industry and you start looking at sort of how people are reacting to this, it's interesting that there's a bunch of people from companies that perhaps move to microservices that are starting to move back towards sort of macroservices and monolithic architecture. So there's an interesting tweet here from someone at Uber who actually, tweeted about the fact they're moving away from microservices to macroservices because, there's a certain scale that needs to be thought about. And most of these people are saying it's not about, just going with microservices. It's about building and choosing the build style that's appropriate for your organization. So there's a growing interest, across the industry in applications that are not based on microservices, but have a really varied and diverse sort of architectural style. So this has sort of been reflected in some surveys that have been happening recently. So there's been some interesting studies done into this sort of change in trend towards what kind of architectural styles are popular. So actually, the Jakarta EE community does a developer survey every year. And actually, if you compare the 2019 and the 2020 sort of questions together about what architectural approaches they plan to use, interestingly, monoliths from 2019 to 2020 went from 12% to 25%. So actually, where most people assume it's everyone's going to microservices, actually, there's a lot of people going back to monoliths that have an increased interest in monoliths once more. And there was a tweet done by Jamie Coleman, who I think is doing a brown bag session with you guys later on at some point, so you'll probably meet him soon. And he did a tweet asking, what kind of architectural styles are you working with? What kind of architectural styles are you interested in? And actually, when you look at this, it's interesting that monolith and microservices are pretty neck and neck in terms of how many people were voting for them. And even though macroservices is a fairly new term, there were still lots of people interested in this sort of macroservice form of architecture. So an interesting sort of analysis of, the community is showing this increased awareness that microservices perhaps aren't the answer in all situations. And actually, this sort of builds into this idea of why microservices fail a lot of the time. And that's because of this term of the distributed monolith. So as more and more people try to deploy their application as microservices, we're seeing a lot more examples of people failing to do this. And that's not a bad thing, because, you know, failure, as a lot of people always say, failure is always an option, because failure is how we learn, failure is how we grow, and how we sort of build better applications. But, you know, in terms of making microservices successful, and sort of comparing it to some of the really successful companies like Spotify and Netflix, you know, not everyone can spend the amount of money that some companies can on the software engineers and the time and the energy and the effort to build really highly efficient, highly effective microservices. But this is sort of what everyone's been attempting to achieve. And, you know, there's many reasons why a microservices project might fail, but one common thread is that they end up being a distributed monolith. And what this means is that essentially what you've got is all the negative traits associated with a distributed application. So things like method calls and procedure calls are much more effective than HTTP network trips. You know, that's just physics. And there are downsides to having lots and lots of microservices that need to be deployed. And if you can't do that independently, maybe you've got your abstractions wrong, or your domain wrong, or maybe even your organization structure is not set up in a way that allows you to sort of set up the microservices independently. So you've got all these downsides of a distributed application, as well as all the downsides of having a monolith, and you've got none of the upsides of either. So really, this is a key reason why a lot of companies are starting to try and take on this challenge to move to microservices, but are coming up short and having this sort of lose-lose situation. So it's actually really important that we talk about sort of the factors involved that help to influence teams when they're trying to choose the correct and the most appropriate architectural approaches. So these are just a few examples of some of the factors that might need to be considered within your organization when you're looking at what kind of architectural style would be best for you to use. So for example, and obviously this is not an end-all goal. There are other factors involved as well, but these are just some of the more common ones that I've picked out. So on the left to right arrows, they indicate sort of a sliding scale, and it's just tendencies. They're not definitive statements here. So for example, with delivery frequency, the delivery frequency of a microservice is likely to be much higher than a monolith, but it's not necessarily guaranteed. So not all of these are sort of factual. This is just general tendencies. So often the benefits of a particular architecture also require investment and organizational capacity to deliver them. So if you can't invest in that organizational capacity or the sort of technology required, you may struggle to perhaps deploy more frequency in this example. So it might be better for you not to do microservices. So this can be quite useful to refer to when you're looking at the factors within your own organization and seeing which ones would suit you better. So on the right-hand side, or sort of on the monolithic side, we have the more coarser grain on the left-hand side, and on the right-hand side, we have the more finer grain models like we showed earlier in the presentation. So you can take a look through this and sort of decide for yourself which factors are more important and where your organization sort of sits on this sliding scale to help you choose the best delivery model for your own application. So where does this leave cloud native? The industry has evolved to essentially a point where there's a great appreciation for different architectural styles. But as we saw earlier in the earlier slides, people are only really focusing on microservices when it comes to cloud native specifically. So where does this really leave cloud native? So let's take a look at sort of the reasons for investing in cloud and also sort of what it means to be cloud native based on this. So what we're really looking for. And it's not the technology necessarily or a particular architectural style. So reasons for investing in cloud. Well, the first one is cost. Clouds are essentially, when you break it down, clouds are a way of outsourcing activity. You've got someone running a data center and you've essentially got economies of scale involved. So they're doing it for lots of people, so should hopefully be able to do it for a lot cheaper, and so should be able to pass some of that cost down to you as the client. So it should be cheaper than running your own data center. There's also you've got to think about the dynamics of flexibility involved in using the cloud. So the ability to scale up or down your usage on demand instead of having to provision enough in your data center for your worst case scenario. So ultimately, companies need to make money, and they do this by investing in the right opportunities like cloud. So cost is a really big factor in this. And, with clouds, it can really help to save cost in terms of sort of running your application. We've also got speed. So speed is another important factor to keep in mind. So it can be, quite long in terms of cycles for getting new things provisioned in a data center for you to be able to support a new application, for example. Whereas in cloud and sort of cloud native applications, you can provision in the cloud what you need when you need it. So as long as you have the permissions and obviously the finance, you can provision as and when you need it, which is really helpful. And the last thing is fashion. So that might seem kind of odd, but actually when you think about it, in some respects, we are a fashion industry. New technologies and concepts come along all the time, and they become a fashion that companies want to copy and imitate. We hear about all these success stories and sometimes sort of jump on the bandwagon and try and apply these concepts and technologies without really fully getting an appreciation of why it worked for that particular company and why it maybe wouldn't work for a different company. Perhaps it's the way they work, or perhaps it's different demands on their application. So we do need to be careful about investing in the right reasons. So let's look back at trying to really extract the essence of cloud native and what it really means. So I actually found this definition by Paul Fremantle, which I thought was a really great definition. It doesn't focus on a technology. It doesn't focus on, advertising or promoting a particular architectural style. It just says cloud native applications should work well in a cloud environment. Yeah, they should. That's exactly what they should do. And in this blog post, there's a really interesting analogy that they use, actually, if you want to check it out, where they talk about sort of vehicles and different types of track that they have to go on. For example, like a dirt track or an interstate or a motorway or an autobahn. And the point was that, if you're using something that's been designed for a dirt track, it isn't necessarily going to be ideal for a motorway and vice versa. If you've got a car and you try and take it off road, it's probably not going to be a great experience. So, there are different ways of building things and building applications so that they work well, but all of them can benefit from cloud native. They just need to work well in a cloud environment. So when you're using the cloud, there are things that you may be going to do differently. You're going to maybe design them differently, build and deploy your application in a way that works well in a cloud environment. So, building a dirt car for a dirt track, building a really high Ferrari, for example, for an interstate. When you're building your application, it's about how you design, build, and deploy it so that it works well in a cloud environment. But there isn't one sort of strategy that fits all. So taking the definitions that we saw earlier, I made sort of a word map that focused down on really what they were defining as cloud native. But actually, when we look at this word map, it's not focusing on the right ideas, right? So people are shortcutting to solutions rather than actually what's important. So we actually we rearranged this word map to focus down on what's really important in cloud native. And we came up with this other word map. So there are some really important factors that are picked out in some of those definitions but that are sort of lost along the way because people are too busy focusing on the solution already, which in many of the cases they think is microservices. So here we've got, factors like being loosely coupled, being observable. So, deploying something in someone else's data center and potentially deploying a number of those things, you want to make sure that they're observable for appropriate logging and sort of identifying any bugs or problems. You want it to be scalable. You want speed. So there's lots of important factors here that we picked out. So how do we actually go about realizing those qualities and those factors that we want from cloud native applications? Well, one of the best definitions out there, it's about 9 or 10 years old now, is sort of the concept of a 12-factor application. There's also a book that sort of goes beyond this and touches upon some additional factors, so it goes up to 15 factors. But this is about really being, this 12-factor guide is really technology agnostic. They talk about sort of things you need to do in order to work well on the cloud, like we said in that definition. And it's based on real world experience it was originally created by the guys at Heroku. So this is, all about sort of taking approaches that enable those qualities and those factors that we discussed as being the key to being cloud native. And actually, if we take a look at a sort of a basic application and go through a mapping, we can see how they link together. So here we just have a public cloud and a couple of applications and backing services running in the cloud. And the arrow here that we've got on the diagram kind of loosely represents your delivery pipeline. So things like your repositories, where you're going to pull artifacts down from, or perhaps publish artifacts to. And actually, if we map over onto that, the 12 factors, you can see here how they link into the diagram. So we've got the code base and the pipeline with that build, release, and run, and that dev prod parity. We've got the application and its process model and sort of concurrency, scaling through processes, and the fact that they're sort of disposable. We've got how to handle dependencies and port bindings and backing services. And we've also got this sort of externalized configuration that really enables us to take that configuration between environments. We've also got things like telemetry and also admin processes to sort of administer discrete admin tasks. And then if we go one step further and actually map on top of that, the characteristics and the behaviors we want to see from cloud native applications, you can see here how the 12 factors can enable you to really achieve those. So, having, a build, release, run, having dev prod parity, having a code base, it really enables this sort of rapid way of deploying your application, testing your application. We get loosely coupled from things like the dependencies, having that external configuration. So you can see here how they sort of link together. We've got things like logging, which enables us to have observability. Things like backing services, dependencies, port bindings, and configuration. That's all about loose coupling. So by following the 12 factors, we can achieve the characteristics of cloud native applications without linking to a particular technology or architectural style, being agnostic in that sense. So actually, if we map that to sort of generic technologies that we could potentially use for our application, you can see here how you can utilize those technologies and those tools to be able to build a really cloud native app. And actually, the interesting thing here, when you look at it, is actually, this could be a monolithic or a microservice or a macroservice application. It's not specific to any individual one of those. So actually, this is a general instantiation sort of version of the diagram. But if we take a look at monolithic, literally the only thing that's changed here is maybe a capital letter for my cloud, but just the title. You can see here how actually it's not specific to any type of architectural style. And you could achieve a cloud native application through the 12 factors using this technology with any type of those applications. So whether that's monolithic, microservice, or perhaps multiple microservices or multiple macroservices. So this is just to show you that, you can utilize this technology, you can utilize patterns like the 12-factor application without going into a specific technology, without having to follow the same approach as every other organization in terms of all using microservices, for example. And you can still build a really great cloud native app that can really gain value from the cloud. So in summary, hopefully what I've shown you is that sort of we took a look at a few definitions of cloud native, and we saw that they did have quite a strong association with microservices, but in fact, not everyone in the industry is doing microservices. And actually, cloud native doesn't necessarily explicitly tie with microservices. Microservices can be great and can be really useful for many applications, but it's not a solution for everyone. Cloud native is just about working well in the cloud. So, there's two sort of aspects to this. One is about exploiting cloud from a delivery perspective. So sort of faster time to deliver updates, faster time to get things deployed because the cloud is sort of there and ready to go. And also the potential cost optimizations that we talked about earlier. And in doing so, you sort of need to engineer your application for the cloud. So taking into account the technologies that are available in the cloud and this sort of cloud delivery model, so how you actually go through your pipeline and deploy something into production, how you scale it up, how you scale it down, and so on, needs to be thought about so you can take advantage of the cloud. But that doesn't necessarily mean you have to switch to microservices. So they aren't, universally applicable or required for cloud native. They are an important tool and they are valid for many applications, but that, you do not have to always use them. There are other options. And the key is really for you to understand your specific application needs, understand what your business needs from those applications, and how your organization is set up to be able to deliver those applications. So in considering all of these factors and in doing this sort of analysis, you can then choose the right technologies and the right architectural style to suit your specific particular application. So hopefully the characteristic slide I showed earlier might help you with this sort of analysis and might be a useful tool for you to use. So to give you some useful resources on this, I provided a couple of links here. So there's a couple of articles we've got on our IBM developer site that you might be interested in. And actually the last one is probably the one that I'd recommend the most. If you are interested in getting hands-on with some of the cloud native tech that can, and the cloud native tools that you can utilize to help make your application sort of make the most of the cloud, regardless of what technology you're using, regardless of what architectural style you're using, then head to our interactive sort of tutorial catalog page where you can take a look at, it's an online environment, so you don't need any prereqs installed locally on your machine. And it will take you through many of those different technologies. So take you through things like microprofile and the different APIs you can use from that. It will take you through using Maven or Gradle, deploying using Kubernetes or Docker. So there's lots of useful hands-on interactive free labs that you can take, and they're only about 20 minutes each. So I would definitely recommend that if you'd like to get hands-on with some of this and really learn how you can make the most of the cloud regardless of your application style. So thanks very much. Yeah, as I said, my name's Grace Jansen, my Twitter's there, and I'll answer any questions.